Hi, my name is Dhruv and I'm a tutor at Tutor Here. And this is the first video in a series of 3 videos on circles. So let's get started. Circles are one of the most important and one of the most fundamental things that we encounter in our day-to-day lives. Let's say you see an orbit, or let's say you see a planet. All of these things are in the shapes of circles. When you come to something as molecular and as basic as chemistry, you see that atoms are also in the shapes of circles. When you come to something that is a day-to-day thing and something you see every day, you can say that a wheel is also in the shape of a circle. So I think it's very fitting and it makes a lot of sense that we actually dive deep inside what a circle is and what is the property of a circle, because we see circles in a lot of places and they are all around us. So I think it's fitting to see about this. So let's first define what a circle is. Now, a circle is the set of points that are equidistant from the center. Now, let's actually understand what that means. So here's a sample circle. This is the center of a circle. And what I mean by equidistant points is any point that is lying on the circle is equidistant from the center. So this length right here is equal to this length, which I'm just going to draw from this point. These two lengths are equal. So let me just mark them with an R, because what we call these lengths from the center to the points on the circles are radius, which is right over here. So all these 3 distances are equal, and this is what actually fundamentally defines a circle, that you have equidistant points from the center. So that is the first property, and let's actually just write down an R over here. This is the first thing that we've learned about circles, which is the radius. Now, let's go to the second thing. Let's say I ask you to draw a line inside a circle, and I say, I don't just want any line, I want the biggest line. How would you draw it? So let's do that experimentally. Let me first draw the line from this point here. Okay, this is the first line. I'll draw a line here. Okay, this got bigger. It's getting bigger. So what you can see is that as you're coming towards the center, the lines are getting longer and longer. And the longest line is the one that passes through the center. And that is called the diameter, which is represented in red right over here. So one interesting thing about the diameter is that since it passes through the center, you can see that it passes through this point right over here and this point right over here. So if it is passing through the center, means this distance is R and this distance is also R. So the diameter is twice the length of the radius. So let's just write it down. Let's represent diameter by D. So D is equal to twice the length of radius. So what we've established now is what a radius means and what a diameter means, and what is the relationship between these two. Now let's go to the third thing we want to discuss about. Let's say I start at this point here. I'm standing on this point on the circle, right at the top. And I say, let me walk on the circle in a clockwise direction, means I want to walk in this direction. I'm going to walk like this and like this. All right. So I'm going to go in a clockwise direction and I want to come back on this same point after I walk on this circle. So what would that distance be? Because that is also something very familiar and something that you can think about, walking on the periphery of the circle. So that special thing is called a circumference. That distance on the circle is called the circumference. So let's denote that by a C. Now you can ask, is there something that can relate the circumference to the radius or the diameter? Is there some relationship between them? So that is exactly what olden people thought, because when they discovered a circle, they said, okay, let me find out some relationship between the radius and the circumference. So they brought out some scales. Now, this was not a perfect scale. This was kind of an approximate scale because you're just trying to figure it out. So they tried to figure out the radius and the diameter ratio, all right? So the first time they took a circle which had a circumference as 3, all right? 3 means you're walking around, you're starting from this point, you're walking in a clockwise direction, and you're coming back to the same point. That is the circumference, so that was equal to 3. And the first time they measured the diameter was 1. So they saw that for a circle of circumference 3, you're getting a diameter as 1. And this is approximate because they did not have perfect scale. So this sign is used for approximation. Now they tried it for a different circle, which was a circle of circumference 6. So here we have 6. And they figured out that the diameter for a circle of circumference 6 was 2. So here they started discovering a pattern. They saw that the ratio between the circumference and the diameter is almost equal to 3, almost, not exactly. So they said, okay, let me get a better scale, a better quality scale. Let me dive into this and let me see what is the actual ratio. So they started with the better scale, and they found out that it was not 3. The ratio was actually 3.1. They got a better scale. They found it was 3.14. And they discovered 1 and a 5 and a 9. And this number, this ratio of the circumference and the diameter kept on going, and it was an infinite number. But this is the first 5 digits after the decimal. So they termed this number as pi. All right. So they said that the ratio of the circumference to the diameter of a circle is actually pi. So let's write that down. The ratio of the circumference to the diameter is equal to pi, and pi is represented by this symbol. All right. So if you want to isolate the circumference, you'll multiply both sides by d, and you're going to get circumference is equal to pi d. All right. So this is a relationship between the circumference and the diameter. Now, let's say you want to find out the relationship between the circumference and the radius. That should not be difficult to find, because you already know the relationship between diameter and radius, and diameter is equal to 2 times the radius. So let's substitute that value in this equation. So it will be circumference is equal to 2 pi r, because diameter is equal to 2r. All right. So here is the relationship. So what we've established over here is the relationships between diameter and the radius and the circumference. So let's actually go ahead and solve a few problems and see if we can use these equations that we've just come up with in a good way. All right. So here's the first question. Here you're given that the radius is equal to 3 meters. So the radius is from the center to any point of the circle, and they have said that this is equal to 3. So the formula that we just figured out right now was circumference is equal to 2 pi r. So it will be 2 into pi into 3, and that will be 6 pi. The circumference would be 6 pi. Now let's not multiply pi or substitute the value, because pi has a pretty complex value that you saw over here, 3.14159, and it keeps on going. So let's not do that. Let's leave it as pi. But we know that pi is approximately equal to 3. So this value is going to be 6 into 3 point something. So it'll be, let's say, 18 point something, 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 something. So we know that the answer is along those lines, but just for our convenience, we're going to keep it as 6 pi. All right. Let's go to the next question. So the circumference is equal to 6 meters. So that means, let's say I start from this point. I'm traveling in the circle in a clockwise direction. I travel one full circle, and that is equal to 6 meters. What I want to find out is what is the radius if I've been given the circumference. So what is the radius over here is what we want to find out. So let's use the same formula, which is circumference is equal to 2 pi r. All right, 2 pi r. And what we can do now, since we want to find the radius, let's isolate the radius on one side. So let's divide both sides by 2 pi. So it will be c divided by 2 pi. Okay. And 2 pi r divided by 2 pi would give you a single r. All right. So c is 6. So let's substitute that value. So it will be 6 upon 2 pi. You can factorize 6 divided by 2, which is 3. So your answer is going to be 3 upon pi. This is your radius. Your radius that you figured out is 3 upon pi. And again, let's not solve this complex value. 3 upon pi would be something in the range of 0. Let's say 9 something, because pi is 3.14. If you have 3 in the numerator, you have a slightly bigger number in the denominator. Your answer would be in the 0.9 something. So what we established in this video was what is the radius, what is the diameter, what is the circumference, what is the relationship between these 3 quantities, and how it defines a circle. So thank you so much for watching this video. If you have any questions or any comments, please leave them in the comment section below, and I hope to see you next time. Thank you.